Hey everyone, welcome to Code Pro series. In this video, we explore how .NET garbage collector works, including its generation model, Gen 0, Gen 1 and Gen 2. We will also look at a simple C# code example to see how objects move between generations during garbage collection. Let's get started. Okay, what is garbage collector? GC. The common language runtime is the execution engine of .NET application. One of its core responsibilities is automatically memory management using the garbage collector. So it's saying common language runtime take care of automatic memory management using garbage collector. So garbage collector is helping to release the unused memory. It's been called automatically within the application during the runtime, and it will check if the memory has been utilized by the unused object, so that object will be get destroyed automatically with the help of garbage collector. So it says the garbage collector automatically frees up memory occupied by objects that are no longer in use. So in that way it prevents memory leaks. So if the objects are been not get destroyed or not get collected through the garbage collector, so it will be keep on utilizing the memory of the .NET framework, and at the end it start doing memory leak, or maybe it will be throwing exception out of memory exception. So garbage collector collects all that unused object and release the memory automatically. So it prevents memory leaks and reduces the risk of out of memory exception. Garbage collector in .NET, you don't control when it runs. So it has been done automatically, what it's saying. You don't have to control. It will be done automatically through the .NET framework. It will call automatically through the .NET framework. But you can request a collection. So if you want, you can request a collection just writing a one line of code gc.collect. So in this way you can request a collection to run the garbage collector explicitly. It works in background, it optimizing memories and improving application performance. Let's move to the next slide. Okay, so next slide is more on like garbage collector generations. So in .NET memory, it is divided into three generations: Gen 0, Gen 1, Gen 2. Generation 0, Generation 1 and Generation 2. Garbage collector works more frequently on Generation 0 and less on Generation 2. So objects moves across generation from Generation 0 to 1, 1 to 2 if they survive collections. So let's see in graphical way. This is the reason of .NET memory, managed memory. It is divided into three generations: Generation 0, Generation 1, Generation 2. So Generation 0 is more whenever the new object is created, it will go to the Generation 0. And if they survive for Generation 0, they will move to the Generation 1. Survived object will be on the Generation 1, and which is not in used, not, or it will be not in used. So those objects will be die here only in the generation when the garbage collector will be called automatically called within the .NET framework application. It will first go to the Generation 0, and it will look the object which are not in used, so it will be get disposed, it will be get collected through the garbage collector, and then the garbage collector go to the Generation 1. But in the Generation 0, it will all the unused object has been collected. So the survive objects will be in the now Generation 1. So again, when the garbage collector comes and go to the Generation 1, if the objects are not in used, then it will be get collected, and whatever the more survived object will be, or more rooted or more referenced object will be go to the Generation 2. So in the Generation 2, at the end, the long lived objects will be reside over there in the Generation 2.
So garbage collector, how does it will be go? Generation 0, generation 1, then generation 2. So it will be mostly go to the first in the generation 0. Okay, now let's see in action. So we will write some C# code for to know how the generation works within the garbage collector. So I just created one class, my class, and within my class there is a constructor, and in the constructor I am passing object name string as a parameter. So it's a parameter with parameter constructor, and also I creating one array of large object of int. So it's 1 million, 10 lakhs, 1 million. Okay, 1 million objects I am creating of integer, and I have one destructor. So whenever we will destroy the object of this class, so it will be get called, and whenever we will create the object of this class, the constructor will called, and it will assign the name of the object. Okay, so in my main program I am creating 4 object of my class: object 1, object 2, object 3, and object 4. And just we are not calling any garbage collector. So I just need to know before calling the garbage collector what is the generation, where it will be, in which generation it will be residing, object 1, and in which generation object 2 is residing, object 3 is residing, and object 4 is residing. So gc dot get generation, so it will return me the generation name. Okay, and then what I do, I will nullify my object 1 and object 2. So in this way it will get disposed, or it will get been collected if once the garbage collector will run. So I explicitly run the garbage collector for generation 0. So in this way the object 1 and object 2 gets collected, and then I will display the generation 3 and generation 4, in which generation they are residing. And also just to survived this object 3 and object 4. So in this way the garbage collector will been called, so it will know that the object 3 and object 4 has been rooted, so it will not get collected. That's why I'm just referring in this line. So after garbage collector called for generation 0, this one generation 0, after that I am just curious about what my object 3 and 4 holding in which generation. So that is the thing. Then after that I will call generation 1. I will call garbage collector of generation 1, and then I will again want to know the object 3 and object 4, in which generation they are residing. And then what I will do, I will nullify object 3. I will destroy explicitly object 3, and then I will call garbage collector in generation 2. And again after that I want to know object 4 position, because object 4 is been rooted, or it's get referenced within the program till end. So that object is live, so it will be a more long-lived object, right? So let's run this program. Let me check if there are any debuggers are there. Okay, I will remove all the debuggers, and let's run this program. Okay, so I have created 4 objects, object 1, 2, 3, 4, and those generations are 0. These are the name of that generation. This is object 1, newly created objects are reside into the generation 0. Then I dispose object 2 and object 1. So and then I called garbage collector in the generation 0. So object 3 and object 4 are moved to the generation 1. See, and object 1 and 2 gets collected by the garbage collector. After that, again I called garbage collector, but now I am called on the generation 1. Okay, so see, object 3 and 4 gets moved to the generation 2 because they are rooted, actually they are referenced. Then what I will do, object 3, I have disposed object 3. Then I called garbage collector on generation 2. So see, object 3 is get collected, but object 4 is long lived object, still referring at the till the end of the program. So it is moved to the generation 2. It will be living on the generation 2 only. So see, that's the beauty of the new objects, survived objects, and the long-lived objects, how they are moving from generation to generation. Okay, if I explain into the graphical way, the newly objects are allocated into the generation 0. So what my example is, generation 1, 2 and 3 are in the generation 0. Then if somehow object 1 and 2 are destroyed, are not in used in longer period of time, so and they are residing in the generation 0, so when the garbage collector has been called within the .NET application, so the garbage collector will be called on the generation 0, so it will collect all the unused objects, so those are fade out. And if object 3 and 4 are referenced further, so they are promoted to the generation 1. So see, the generation 1 have the object 3 and 4. So now generation 1 holding 3 and 4. Still they are more referenced, so when the garbage collector will be called and it will go to the generation 1, it will collect all the unused object, but if it is rooted, then it will be, that objects will be get promoted to the generation 2. So in the generation 2, 3 and 4 will be residing now. So how does it work? So when the generation 1, when the garbage collector triggers for generation 1, so some objects get been collected, fade out, and some objects are promoted to the generation 2. So it will move to the generation 2. So promoted objects are in the generation 2, and unused objects are get collected from the garbage collector. And so that's why the long lived objects has been reside into the generation 2. So whenever the garbage collector starts, garbage collector triggers to the generation 0, 1, then 2, and within the 2, the objects are remains in the generation 2 only, long lived objects, and short lived objects get collected and removed. So finally, garbage collector, only long lived objects survived in generation 2. Also, I would like to let you know this gc dot collect 0, gc dot collect 1, gc dot collect 2. This is not a good practice in writing a code in this way in your application, calling a garbage collector explicitly. In fact, even passing the name of the generation, that is not a good practice while writing a code or in running this code into the production. So that is just for a demo, giving a demo to you guys. How does the garbage collection actually runs within the .NET environment from 0, 0 to 1, 1 to 2, like this. So that's just for demo purpose.
Thank you so much for watching. If you like the video, please subscribe to Code Pro series. Hit the bell icon so you don't miss any new tutorials. And if you have any questions, just leave a comment below. I will be happy to reply. See you in the next video. And until then, keep learning and keep coding. See you.